Okay, so this lesson we're going to start talking about equations in two variables. We spent the last two lessons solving one-step problems where all we had to do was either add, subtract, multiply, or divide to unhook a number from a variable. Now what we're going to do is learn about an equation in two variables, because eventually what we're going to see are some problems where you have to unhook some things from variables where it doesn't give you a number answer but an equation on the other side. So you're going to end up with things like y equals 2x or y equals 3/4 x plus 7. It's going to give us a lot of different things here. Equations in two variables are going to be something that you see early and often in Algebra 1. So first of all, I'd like to go over the definition here. It says an equation in two variables represents two quantities that change in relationship to one another. A solution of an equation in two variables is an ordered pair that makes the equation true. So if we look at example 1, what they're giving us is a problem where they're saying, okay, if I have an equation, y is equal to 2x, for instance, on this first one. So I have y equals 2 times x. And then they're giving us, for a given, they're giving us an ordered pair 3, 6. They're saying, is 3, 6 a solution for this? Well, before we can do anything, we have to know where to plug these numbers in. So again, in any ordered pair, we should know that the ordered pair goes x, y. So what we're going to do is take this value 3 and we're going to plug it in for x. We're going to take this value 6 and we're going to plug it in for y. So now it's going to say 6 is equal to 2, which is from the formula, times 3. And they're saying, is this a true statement? Well, we can say, yeah, 6 is equal to 2 times 3, which is also 6. That checks out. So that means that this point right here, 3, 6, is a solution of the system. Now on the second example, for instance, we have this problem here where y is equal to 4x minus 3. And they're giving us a whole new coordinate point. They're saying the coordinate point is going to be 4, 12. We'll squeeze that in there. So now again, I have to know where to properly plug these things in. 4 is x, 12 is y. The coordinate points always go x, y. So I go ahead and plug in 12 equals 4 times 4 was my value for x, minus 3. Well, I have 12 is equal to 4 times 4, which is 16, minus 3. 16 minus 3 does not give me 12, it gives me 13. So since those two things are not equal, I say no, 412 is not a solution for that particular equation. It doesn't mean that it doesn't have answers, it just means that 412 is not one of them. A couple of definitions here after this example you guys want to keep available for your notes. It says you can use equations in two variables to represent situations involving two related quantities. The variable representing the quantity that can change freely is called the independent variable, and the other variable is called the dependent variable because it depends on the independent. In any case where you see x and y, your x variable, your input variable, is always going to be the independent variable. When you plug something in and you do an operation on it, so for example, I'm going to plug in a number for x and I'm going to operate on that number with times 2, it's going to directly affect what happens to y. You can't say I'm going to plug in something for x and it's not going to have any effect on y, because the whole stipulation for y existing is taking 2 times the value x. So you're going to learn how to isolate y where you choose what the rule is for that variable. Example 2, it says the equation y is equal to 128 minus 8x gives the amount y in fluid ounces of milk remaining in a gallon jug after you pour x cups. First, you're supposed to identify the independent and dependent variables in this problem. So the independent variable in this problem is going to be the amount y remaining. Again, it's always going to be the y value, the y remaining, because it depends on how many x cups you pour out of the jug of milk. So again, y is the independent, or excuse me, x is the independent as always, y is the dependent. Example B, it says how much milk remains in the jug after you pour 10 cups. Well, again, if I say 10 cups, I'm talking about x equals 10, and that makes this problem very easy. Y is equal to 128 minus 8 times that 10, because I'm going to pour 10 cups. Well, if I am going to say y equals 128 minus 80, because I'm going to pour 80 out of this 80 ounces out of this jug of milk, and I take 128 minus 80, and I get y is equal to 48, and I believe that's ounces, fluid ounces, so we'll just put OZ. Okay, so that's the remaining number of ounces in the jug of milk after 10 cups of milk are poured. A key idea here, so we see that we have values for x and y. Again, independent is associated with our x, and dependent is associated with our y variable. You see a table of values here where x is equal to 1, 2, and 3, y is equal to 3, 4, and 5. The table is given by this function right here. So the way they do this is they say y is equal to x plus 2, and x is whatever we pick to plug in. The book chose 1, 2, and 3. So they said, okay, my output y is equal to 1 plus 2. That's how they arrived at the value 3 up above. Then for the second point, they said the value y is equal to 2 plus 2. That's how they arrived at the value 4. And 3 plus 2 likewise is 5. Anytime you're given x and y coordinates, they can be written as coordinate points or ordered pairs, and they can be graphed, and we've learned about how to graph those last chapter. Just so you know, anything in two variables gives us some kind of linear function. So if you are able to isolate y, we will be able to put things in what we call slope-intercept form in the future, but we isolate our dependent variable, plug in for our independent variable, and then we will get a nice line like this with all these types of functions. It may not always go up. Sometimes it's going to go down, sometimes it's going to be straight up and down, sometimes it's going to be flat like this, but they are all linear nonetheless. We have an example here. It says an athlete burns 200 calories weightlifting. The athlete then works out on an elliptical trainer that burns 10 calories for every minute. Write and graph an equation in two variables that represents the total number of calories burned during this workout. So again, we want to know how many total calories. And in order to find that, it's going to change by every number of minutes that this person stays on an elliptical. So first of all, weightlifting isn't going to change. That 200 calories is going to remain 200 calories. But every minute we spend on an elliptical trainer, it's going to burn another 10 calories. So every time we spend another minute, it's going to go up by a factor of 10. So if I spend 1 minute, I'm going to say 10 plus 200. If I spend 2 minutes, 2 times 10 is 20 times 200. And as you can see here, it increases. For every 10 minutes I spend on this, it'll increase by 100 or 200 or 300. So they're saying instead of going 1, 2, 3, they're saying, okay, I spent 10 minutes on an elliptical. That's going to be 10 times 10 is 100, plus 200 is 300 total calories burned right there. Or they're saying, okay, I'm not going to go 11 minutes. Maybe I'll go a whole nother 10. So they're going to say 20 times 10 is 200, plus another 200 is 400. And that's how they arrive at these outputs. But you guys can see that the more time that is spent on the elliptical trainer, the more calories are burned. So now you guys finally have an example on your own, and what you want to do here is a couple things. First of all, I want you to try and attempt writing an equation in terms of y equals something x plus something. So in other words, one of these numbers should get the variable x with it, the other one shouldn't. Once you do that, after you write an equation for it, I want you to, instead of doing a graph, give me a table of values, and let's say for the hours 1, 2, and 3 hours. So let's say we're going to rent a kayak for up to 3 hours. Before you can fill out this table, you need to write me a function. Once you write the function, I'll kind of show you what a graph would look like for it, but go ahead and try to fill out this table. Okay, so hopefully you've made a valid attempt at it. Again, it's very hard to do this stuff if you never try it on your own. If you just wait for me to do it for you over and over again, it's really never going to come to you. So please make sure you try these. The first equation here is going to be y is equal to 8, because 8 is happening every hour that I stay in that kayak, and the initial fee is 25, so I have to add that 25 onto it. And now to fill out the table, so again, if you didn't get this, pause the video, write this down, and plug in those 3 values for x, 1, 2, and 3. Now that I have the values for x, I know that it's going to cost $33 for 1 hour. For 2 hours, it's going to be 16 plus 25, which is going to give me 41. And then for the third hour, it's going to be 24 plus 25, which is 49. So those would be the costs for 3 hours. Again, if you were to graph something that looks like this, your starting fee is going to be at $25, and it's going to increase by 8. So it's going to be a function that goes up like this slightly, because for every hour you pay another $8, and it's going to go up like that. You'll have a couple other problems where they make you use the distance formula. My video kind of cut it off here. I'll just kind of write this in here, you guys. You want this formula, distance equals rate times time. You've probably seen this in a science class before. So if they say your times are 1, 2, and 4 hours, and they give you a rate of some kind, in this particular problem, it's 40 miles per hour. So for every increment of time, you're going to multiply by 40, and that's how they get those outputs there. You guys can look over those table of values, but you should kind of be able to catch on to it at this point. So if you see a distance formula problem in your homework, just remember, here's the formula, and you plug it in all the same. Your rate is going to be something that's given, and your time is going to be in the table. So given is going to be your rate, and again, your time will be in the table values.